The A320 has 3 hydraulic systems, each with its own hydraulic reservoir that are designated as green, blue, and yellow. Each system is designed to operate automatically and continuously during flight operations. There are 2 engine-driven pumps, one on engine number 1 for the green system and one on engine number 2 for the yellow system. There is a power transfer unit between the green and yellow systems that enables one system to pressurize the other if an engine-driven pump is inoperative. Hydraulic fluid cannot be transferred from one system to another. The yellow system also has an electric motor-driven pump that can pressurize the yellow system, and through the PTU can also pressurize the green system. This pump may be used if the aircraft requires hydraulic pressure when the engines are not running, but the primary purpose of the pump is to operate the cargo door. The yellow system is also equipped with a hand pump that allows manual pressurization of the system to operate the cargo doors when the aircraft is not electrically powered. The blue system is normally pressurized by an electric motor-driven pump, and during an emergency, the blue system can alternately be pressurized by the ram air turbine. Normal system operating pressure for all 3 systems is 3,000 psi. However, the RAT pressure to the blue system is approximately 2,500 psi. The controls for the hydraulic system are on the overhead panel. Take a moment to identify each switch with the components on the diagram. Indications consist of memos on the EWD and on the ECAM hydraulic page. Notice the ECAM page shows the main system components and the flow of the hydraulic pressure. Now take a moment to associate the switches on the panel with the components on the ECAM page. Let's look closely at each system in more detail. The green system is normally pressurized by a pump driven by engine 1, and it normally operates whenever the engine is running. On this diagram, you see that the fluid from the green reservoir to engine 1 pump is provided through the open fire shutoff valve. Closing the fire shutoff valve interrupts the flow of fluid to the engine 1 pump. Also, this diagram shows the system accumulator on the output of the pump that maintains system pressure during high surge demands. The blue system is normally pressurized by an electric pump. However, in an emergency, a pump driven by a ram air turbine can pressurize the system. The blue system electric pump is operated normally in an automatic mode. In auto, it operates continuously in flight, but on the ground, the electric pump operates if one engine is running and automatically shuts off if both engines are not running. When blue system pump operation on the ground is required, the crew can press the blue pump override push button on the hydraulic maintenance panel. This action overrides the automatic shutdown of this pump during ground operations. The RAT will automatically drop out into the windstream if electrical power is lost or both engines fail, or it can be deployed manually. Therefore, the RAT provides backup emergency pressure. This system also has a system accumulator to maintain system pressure during high surge demands. The yellow system is normally pressurized by a pump driven by engine 2, and it will normally operate whenever the engine is running. As with the green system, a fire shutoff valve controls the flow of fluid to this engine-driven pump. An electric pump is installed that can be selected on to provide yellow system pressure. As with the other 2 systems, a system accumulator maintains system pressure during high surge demands. The yellow system is also equipped with a hand pump to pressurize the yellow system. It is located in the yellow system ground service panel. This hand pump allows personnel to pressurize the yellow system for operation of the cargo doors when no electrical power is available. A bidirectional power transfer unit enables the yellow system to pressurize the green system and vice versa. This diagram shows how the reservoirs remain pressurized by either the bleed air from engine 1 or from the cross-bleed duct when engine 1 bleed is not sufficient. A pressurized reservoir provides the motivation to keep positive fluid flow to the hydraulic pumps. Without pressure, the pumps may cavitate at higher altitudes. This diagram shows how the system is filtered to maintain clean fluid. Filters are a maintenance function. Let's look at the system distribution to the using components. The first thing to point out is that the heavy load users are drawn at the top of this diagram, just above the priority valves. A priority valve will close to cut off pressure to the heavy load users if the respective system pressure is low. This feature maintains pressure for the other higher priority components, such as primary flight controls and wingtip brakes for flight operations, and reversers and brakes for ground operations. On this frame, you should familiarize yourself with the source of pressure for the various components. Notice that many items are pressurized by 2 or more systems. Finally, notice that the emergency electrical generator is pressurized by the blue system, and it is a high load item on that system. Before we leave this diagram, we'll describe the leak measurement valves. Each leak measurement valve measures the leakage in each system. Each valve can be manually closed by the operation of the leak measurement valves push button on the maintenance panel. These push buttons are for ground maintenance only. Okay, that completes our introduction to the A320 hydraulic system. Let's answer some questions.